Hi there, my name is Marcus. I'm going to be demonstrating the distribution pre-electrification tool to you. This is a software application for estimating the ADMD, the consumption and load profile of 60 or more domestic customers. We developed DTPET after extensive research and massive data collection during the course of the NRS Load Research Project from 1995 onwards. The load predictions in the software are based on an extensive program of data collection from domestic customers in the field. The result of the predictions have been confirmed to closely follow what was actually measured from these customers. Several South African national standards covering planning and design for domestic electrical networks are based on the load models in this tool. Published customer parameters in NRS 034, that's SANS 507, the CSIR Redbook and Eskom's Distribution Master Planning Standard all refer to the load models in this tool. Bear in mind the software has a user manual. In the user manual you'll find supplementary information on the application, how to use it and the background behind it. Please bear in mind the software is backed up by a huge amount of domestic electrical load research. At the end of this video you'll find links to this research. Okay, so this is what the software looks like when you start it up. Please bear in mind that it is an HTML application, so it does sometimes take a while to show you the screen that you're looking at here. That's because it checks with the server for whether there are any updates and then comes back with the updates if there are any. Okay, now let's just look at this user interface. We've got an input tab, which is this page that we're looking at here. And then the rest of the tabs across the top are summary tabs. If you look at the input tab, then you've got a panel on the left hand side which allows you to enter income information and other parameters about the community you're doing a forecast for. And on the bottom panel you have empty data fields which allow you to capture information about the project that you are doing the forecast for. In the center panel there is a map, and the purpose of this map is to locate where a project is in South Africa, and one does that by clicking on the map. So here we've just clicked on a map. Now notice on the bottom right hand corner the position that you indicate on the map is given some auxiliary information. You've got your GPS coordinates, the province that it's in and the municipality that it's in, as well as your climatic severity index, which is something that indicates how severe the climate is. And you have your nearest South African Weather Bureau weather station. Across the top of the input panel we have 4 buttons. It allows you to calculate an estimate for the community that you're trying to produce predictions for. It allows you to save and load a group of settings for this prediction, and it also allows you to produce a report of your entire prediction. That writes the report to a PDF file. Okay, so now I'm going to take you through the process of doing a forecast. Basically, this software works with using an estimate of the income of the customers for an electrification project, and in doing so, one uses the drop-down menu here to select an income level. The second drop-down menu allows you to enter the year in which that income was estimated. This is to allow us to work backwards in time as well as slightly forward in time. The next drop-down is for the current limit on the circuit breaker. I have suggested manually or automatically. Let's leave it on automatic for now. The risk level of the forecast, that allows you to specify if you want to have an average forecast or a 90% forecast. In other words, it allows you to cater for additional risk, and that will obviously give you a somewhat higher forecast. Next is the floor area, and this is an adjustment for the higher income ranges that allows you to add a bit more of an accent to the floor area, saying that the houses for this particular forecast are larger or smaller than the average which one expects for houses of that income level. It is only operational in the higher income levels, however. Following drop-down is for free basic electricity units. What we've done here is to include price elasticity of consumption. and we've worked it into the model. This price elasticity of consumption was measured directly during the free basic electricity project. So bottom line is, if your customers are expected to get free basic electricity, then dial in the number of units which they would typically get per month with this drop-down list. The next drop-down list is for theft. Now, the theft levels that you're expecting from this community, it's a judgment call here about whether to add on additional consumption for theft or not onto your forecast. Would you design a network for theft or not? That's a policy issue. Let's leave it at 0 for now. The following drop-down is for the income growth per year. Now, this is a growth in the actual or the real income per year, and that is in excess of inflation. So if we're saying that our area is not getting wealthier overall, in other words, the living standard of the area that we're forecasting is not increasing, then we keep this at 0. Okay, so those are all the income variables that we've selected. If we wish to save a project later on, then we fill in the data fields here, which basically allows us to do some tracking, and these fields are then also stored with any forecast that is stored, and they are also included in any report which is produced. Right, so now we've entered all our input parameters and we push calculate. And what happens now is that the software goes away and it looks up the forecast for this community in that area in the country. And the forecast is now ready on the tabs on the top for viewing. If we go to summary, you can look across the tabs on the summary, and it shows you for years 1 to year 15 what the forecasted energy is in column 2, what the forecasted ADMD is in column 3, and what the alpha and beta values of the demand are at the time of the peak, and what the suggested or recommended circuit breaker value is. So our community for this input value that we've selected starts at 149 units per household per month. That's an average throughout the year, and goes up to 198 units per household per month. The ADMD likewise starts at 0.65 and goes up to 0.94. Okay, so that's the forecast actually for the consumption and the demand and the parameters of the demand over a 15-year time span. The forecast that you have here on the grid, one can save this. If I go to save, it'll allow me to save this forecast as a CSV file. Okay, so another feature of this output tab is that you can highlight all of the cells that you want to copy if you wish to copy. And you then push the usual Windows Control-C, and if you pop along to Excel, you can then paste this table as is into Excel or into a Word document for reporting. Very handy feature, this. Looking at the energy forecast, this is basically just a straight graphic, and it shows exactly the same information that was in the previous table, but now you have it in a graph form. The years 1 to 15, and your energy starting at roughly 150 units and going up to almost 200 units. There are other options now to save the values from this graph, or you can save the graphic in an image form and then take it across to your favorite reporting software. Now, the demand graphic shows you what your ADMD is going to be over the same time window, and there's no difference here in the information that was presented in the summary table. It shows your ADMD starting from 0.65 and heading up to somewhere around 0.84 kVA ADMD at the time of the peak. If you highlight on any of these bars, you will see it gives you also a write-out of what exactly the value is at the peak of this graph. This graph shows a cumulative probability function for the demand at the time of the peak for years 4, 7 and year 15. Again, one can save this graph as you wish. If you want to see a normal probability density function, then just uncheck this box here, and you get your typical curve for low-income customers. In other words, the customers are very much clustered down on the low-end side with a few high-end customers at the time of the peak. So this tells you what's happening with your customers at the time of the peak. They're not all the same. There is a variance amongst them, and this probability density function shows you what that variance looks like. This gives you an estimated load shape for these customers in year 7, month August, and for a weekday. So this is an hourly load profile shape for a weekday in August of year 7. You can see that the load shape has got a morning peak and an evening peak, and you've got these little limit markers which give you an upper bound and a lower bound for the standard deviation around the hourly load profile at any particular time of day. You'll notice that the standard deviation around the load profile is not the same for every time of day, and the default at the moment is for 2 standard deviations. 2 standard deviations means that 95% of the time the value of this mean is going to lie between the top marker and the bottom marker. If you look at the cursor, where the cursor is, again, you are able to see the values for each bar when you move on to them with the mouse. If you don't like what is shown at year 7, then you can simply use the drop-down box and move to a different year. So this is the demand forecast for year 3 in August weekday. And if you want to look at a higher year, say year 15, then simply navigate to year 15 and you see you have your load growth. The axes on this graph are auto-scaling, so just keep an eye open for that when you are switching between load shapes. If I wanted to have a look at what January looked like in year 15, then I would go through and look at January. Now, interesting thing, depending on where you are in the country, you'll find that the uncertainty around the load profile changes according to the season. I'm going to go back to July now, reset, and back to year 7. If you want to have a look at the difference between a weekday and a weekend for these particular customers, then just dial across to your typical Saturday and you see the load shape changing, and one can also inspect the model Sunday behavior. Same as in the previous tabs, it is possible to save the values of this graph either as an image or as values. So all of the data on the graph is very easy to capture for reporting purposes. This has been a brief overview of the DTPET software. Thanks so much for watching. Have a great day. Goodbye.